xShape is a browser-based CAD application on the 3DEXPERIENCE platform. It is used to model organic shapes that would be difficult to create in XDesign. It uses subdivision or sub-D surfaces. These surfaces are covered with an easily manipulated polygon mesh. The sub-D surfaces can be reshaped by manually changing the topology, by pushing, pulling, dragging, or rotating elements of the surface. In addition, there are many shaping tools that can be applied directly to the topology. After editing, the sub-D surface is automatically refined to create a smooth curvature continuous or G2 surface. These surfaces are eventually converted to NURB or non-uniform rational B-spline surfaces so that they can be used with XDesign and SolidWorks. xShape and its companion XApp, XDesign, can be used on any device anywhere. Models created in xShape can be edited in XDesign and vice versa. Swapping between the apps is quick and easy, and similar to XDesign, file storage is in the cloud. xShape offers a large selection of 3D primitive subdivision shapes. The fully enclosed surfaces, box, quad ball, cylinder, globe, torus, cone, and pyramid. You can also build using 2D primitive subdivision shapes. The flat surfaces rectangle, disc, and ring. These shapes can be created, edited, and combined to form more complex models. Each primitive subdivision shape is broken down into quad shapes by intersecting edge loops that go around the body. Each quad is a face bordered by edges with vertices at the ends. Selecting this geometry can be done manually with a click of the mouse or in large groups using box selection. The tool used to manipulate this geometry, once selected, is called a robot. The robot is a set of coordinate axes used to perform push-pull, rotate, and scaling operations. In this lesson, we'll create a model of an iron from a 3D primitive subdivision shape. In this case, a box. This lesson will show how to model in xShape, including making some basic changes and leveraging XDesign. Let's get started. After starting xShape, I'll click Start a New Component. After selecting the collaborative space to store the component, I'll click OK. Next, I'll go to the xShape action bar, click the Subdivision tab, and click Box. You'll see a preview of the box on your cursor. Hover near the intersection of the planes and click to place the box. The subdivision dialog, with the default placement settings and on-screen flags, appears. These settings can be used to modify the overall size and topology of the box. We'll use the defaults, so click OK. After creation, the entire surface remains selected, so I'll just click Air off to the side of the geometry to clear the selection. Another option is to press the Escape key. At the top of the screen is the Subdivision Environment toolbar. It will remain on the screen while the subdivision surface is active and being edited. Although you can have many subdivision surfaces, only one can be active at a time. Click Show Mesh Cage to toggle on the control cage of the body. This option reveals the cage that surrounds the surface body. It is your choice to work with the cage on or off. We'll try it both ways, but for now, let's use the cage. The most direct way to edit a subdivision surface is to push or pull geometry. That is, pushing into the body or pulling away from it. That geometry can be the faces, edges, or vertices of the surface. Let's try pulling several faces at once. The robot is key to all pushing, pulling, and rotating actions. It appears when one or more faces, edges, or vertices are selected. I'll control select these three adjacent faces and the robot will appear. I'll pull on one of the robot's axes away from the surface about 80 to 90 millimeters. There's really no need to be exact here. Pulling the axis ensures that you are manipulating the body in that single direction only. Next, I'll control select 3 more faces, this time on the top, and pull the axis of the robot up about 45 millimeters. Now let's try working without the cage. Turn off the mesh cage by clicking Show Mesh Cage again. This is the actual surface of the model without the cage. You can manipulate the faces, edges, and vertices on the surface in the same way. Let's try it. First, let's try an easier way to select and shape geometry using an orthographic view. Press the space bar to bring up the view cube and orient the model so we're looking at the front. I'll press the F key to zoom the model to fit. Note that there are many ways to change the view orientation, and you'll find yourself working in orthographic views like this one a lot. Box selection is another key to using the push-pull technique effectively. It allows you to select through the model so that you not only pick the vertex you see, but also any vertices inside the box through the surface. In fact, this type of selection works the same way for the selection of faces, edges, and vertices. Let's use box selection to select the vertices that we want to move. First, box select over the vertex in the upper right corner of the model. 2 vertices are actually selected. The robot appears, but it is oriented differently. This is because it always aligns to the full set of selected geometry. Dragging the planar section of the robot allows you to drag along the plane formed by the 2 adjacent axes. I'll push the vertices inward, reshaping the outer edge of the surface. I'll use box selection again to select all the vertices along the left edge of the model, and I'll pull them about 50 millimeters. As you can see, this method of selection, combined with pushing and pulling, is a very common procedure. Symmetry is another important tool. It allows you to work on one side of the model and have all the changes automatically applied to the other. You can actually make edits on either side of the symmetry plane. To enable it, click Symmetry on the action bar and select the symmetry plane, in this example, the YZ plane, and click OK. When symmetry is active, it appears on the surface as a green edge. The next step is to create a crease on the lower edges of the surface, representing the bottom of the iron. Crease creates a bend along the edges. I'll click Crease and select the edges around the bottom of the model. Note that the crease is applied to both sides of the model at the same time. This is due to the symmetry. To stop creating creases, press the Escape key or just click the Crease button again. Subdivision surfaces are composed of 4-sided face patches in a grid, which are in turn defined by the number of control loops. These are the edge loops that go around the body. If you want to change the number of loops, you can insert them or delete them. Less loops can be better in some cases. It is good practice to try to determine how few edge loops you need in order to achieve your shape. Let's remove one loop. Click Delete Faces/Loops and select the edge loop to delete it. In a previous step, we found that the robot may not always align with the global coordinate system. This time we'll realign the robot so that it does. I'll box select some vertices and the robot will appear, as always, aligned with those entities, but in this case at a slight angle. Right-click on the robot's center white dot and click Set as XYZ. Now we can pull those vertices about 20 millimeters using the standard axes. After making a few more adjustments, let's set up for the next command. Box select the bottom row of vertices and drag them up just a few millimeters. just enough to expose the planes behind the model. They look planar, but they may be a little off. Now click Align Mesh Points and select the option Align Vertices to Entity. Click in the Entities field and box select the same group of vertices. Click in the Geometry field and select the XY plane. The result is the vertices being coincident with the plane. After making some further adjustments, I'll disable Symmetry by clicking Symmetry again. This time we'll take a look at the multi-purpose Extrude command. It can do many things, but this time it will be used to create a hole in the subdivision surface. Click Extrude and select two opposing faces, one on each side of the surface. After the first selection, it looks like it's adding material. The second selection changed it to a removal. Toggle the command off by clicking the Extrude button again. After making a few more adjustments, we'll use Extrude in a different way with a different toolbar. Control select the two rear faces and then click Extrude from the Quick Command toolbar. And extrusion, combining the two faces, is added. Here's another great option, aligning a set of vertices to align. After adjusting the extrusion, box select vertices and click Line Align from the Quick Command toolbar. The manipulator is aligned with dots at the center and the ends. Drag the lower dot away to slant the line of vertices. Click OK. After adjustments to the base, click Scale by Distance. This is a way to scale the entire surface to a specific length. When the manipulator appears, drag and snap the end dots onto vertices, defining the length to scale. In the dialog box, type 304 and hit Enter. And click OK. This length is now exactly 304 millimeters or 1 foot long. Now we're ready to finish this surface and knit it into a solid. Make sure that the knit option on the subdivision environment toolbar is pressed and click OK to exit the subdivision environment. In a single step, the body is converted to a NURB surface and is made into a solid. All of this shaping has been done using a single box subdivision surface, but we can add more geometry. Let's add a different type, a cylinder, to the model. Click Cylinder and note that the shape will orient normal to the faces and edges that you float over. Place it on a vertex of the iron. Set the scale to 25 and click OK. Flex is used to deform the selected geometry. Click Flex and box select two vertical rows of vertices. Drag the axis about 6 or 7 millimeters. Now box select the opposite set of vertices and drag the robot back to its origin, making both sides roughly equal. Click OK. In order to move the body, we'll box select the entire cylinder. Don't worry about selecting the other body, only the cylinder is active. Drag the axis down into the iron so that it sinks in and overlaps the other solid. To finish, exit the subdivision environment, again making sure that the knit option is selected. Again, the subdivision surface becomes a solid. Now I'll simply press the X key to switch from xShape to xDesign. You can switch back to xShape the same way. All of the geometry created in xShape, 2 subdivision surfaces and 2 knit surfaces, appears in the Design Manager. We now have 2 individual solids overlapping each other. Let's combine them into one. Click the Features tab the Split pull down and combine. Click the Add option, select both the iron and the button bodies, and click OK. Next, we'll need a new sketch on the XY plane to add a circle, roughly in the center of the handle, and a dimension. I'll extrude the circle using a blind depth so the boss protrudes through the geometry, and then click OK. Next, I'll click Fillet and add fillets around the base and the top of the boss, as well as the base of the button. We're done in XDesign for now, so I'll select the subdivision feature that created the iron body in the Design Manager, and then click Edit Feature on the context toolbar. Note that you will be switched back to xShape with the iron body being edited. Back in xShape, I'll box select the vertices around the bottom of the hole and push them down, increasing the size of the hole. I'll click OK to exit the subdivision environment. Note that the extrude and fillets created in XDesign rebuild properly. To finish up the model, I'll select the Extrude feature in the Design Manager and click Edit Feature. We'll change the depth of the extrusion to be a little shorter and click OK. Note that we are still in xShape. How about the color? I'll click on the name in the Design Manager and click Color. After selecting a color, I'll click OK to apply it to the entire model. For the final step, we'll rename and save the model the physical product. In the Design Manager tree, click the three dots to the right of the physical property name. Type directly into the Design Manager to rename your model. Then click Save on the action bar. It has been saved to the cloud and can be retrieved using that name.